we are going to discuss on the experiment for verification of maximum power transfer theorem. So today we are going to talk about the experiment on maximum power transfer theorem verification. The circuit diagram that we are going to use for this experiment is shown here. It comprises an AC voltage source, single phase AC 220 volt AC source. Then we have a barrier, the output of which will go to a resistor which is fixed, and this resistor will act as a fixed resistance on the source side. Then we connect it through an ammeter, and then we have a variable load on the other side. Our intention or objective is to determine the value of RL, the load resistance, for which the transfer of power from the source to the load will be maximum. The theoretical coverage of this is probably already done in your class, so we are going to talk about this experimental part of this experiment. So the equipment we are using comprises a rheostat which is rated for 75 ohms and 2.5 amperes, another rheostat of 100 ohms and 2.5 amperes, and we have a voltmeter and an ammeter. Since this is an AC circuit, we are using moving iron type instruments. The ranges available on the voltmeter are 0, 75 volts, 100 volts and 300 volts. Similarly, the ranges available for this ammeter are 1 and 2 amperes. So before starting, we need to first choose or select proper ranges of this equipment so that we get proper readings. As we can see from this equipment, that the maximum current that we can allow in the circuit is to be limited to 2 amperes. So under no circumstances the current through the circuit should exceed 2 amperes, which means that the voltage that we need to apply has to be limited to around 20 volts, because this RS we are setting at around 12 to 12.5 ohms in this experiment. So obviously the voltage that we are applying, which comes as the output of this barrier, is to be limited as 12.5 multiplied by 2, which is around 25 volts. So we need to choose the lowest available range on this voltmeter for conducting this experiment. So as a first step, we are using this rheostat to set the source resistance. So we have put this terminal at this point and we need to measure the resistance. We are using a multimeter for the purpose. We have selected this option so that we can measure this ohmic value or the resistance value of this rheostat. As a first step, we are measuring the resistance of the source resistor. We are measuring the resistor using a multimeter, and the resistance comes out to be 11.2 ohms. So we have made this experimental setup. This is the variac which is being supplied from this AC source. The output of the variac goes to a rheostat. This rheostat has been set to a value of 11.2 ohms, and this is acting as the source side resistance. From the rheostat, we have connected an ammeter. The other side of the ammeter goes to another rheostat which is acting as the load resistor, and which we are going to vary during the course of our experiment. We have connected a voltmeter across the load so that we can measure the voltage across load at each step. Now you have to be careful and you have to note the maximum and the minimum position of the resistances. For example, you can see this pointer is placed in this resistance in such a way so that this is the minimum resistance position. So similarly for this rheostat, if this pointer is placed here, this will be the minimum resistance position, because the current will enter through here, go through a low resistance path, and it will come out without going through this resistance values. Similarly, if this pointer is put here, then this entire current will pass through this resistive path, and therefore this point signifies the maximum resistance position. So now let us start this experiment. As I have mentioned, the maximum allowable value of current is 2 amperes for this circuit. So we will keep the load resistance in its minimum position, and we will vary this variac to set up a current of around 1.8 amperes, which is slightly lower than the allowable value of 2 amps. So let us set up the current first. So the current is set to a value of 1.8 ohms, as you can see. And since the load resistor is in minimum resistance position, it's almost zero resistance. Therefore, you are getting a voltage of 0 volt across the load. So this is the first reading you need to note, the value of the ammeter current and the voltmeter reading. As a next step, you need to vary this load resistor in steps. So I am changing the position of this load resistor and see the current has changed to a value of around 1.56 amperes. So you need to monitor this value, record this value. The voltmeter reading is very low, which is why I'll be using a multimeter to measure the voltage. So let me set the voltmeter. And as you can see, the voltmeter reads 2.97 volts. So you need to record this value. Next, we will further shift the position of this resistor. And as you can see, you are getting a current of around 1.2 amperes in this ammeter. Again, you need to measure the voltage across the load, which comes out to be 7.58 volts. Which comes out to be 7.58 volts. As you can see. So you need to repeat these steps in series and you need to continue till you reach the other end of this rheostat. So here we have tabulated a few values that we obtained from conducting the experiment. So we have noted down the voltages, the currents. We have calculated the corresponding load resistance value by dividing the voltage by current. And we have calculated the power also, which can either be obtained by multiplying the voltage with current, since this is a DC circuit with only purely resistive elements, or else we can also do I square into R to find the power at every step. As you can see, if you look at the power value, from 0 it keeps on increasing to about this value 10.39, then it starts reducing 10.38, it goes to 10.199 and decreases further 9.3. Now you look at the load resistance value, the load resistance here is 9.24 and in the next step it is 12.26 corresponding to a power value of 10.38 watts, which means whenever the load resistance is between 9.24 ohms and 12.26 ohms, the maximum power point lies in between these two. And if you remember, we had set our source resistor to 11.2 ohms, which is being verified from this tabulated data, because the maximum power point is lying in between these two.